Let's finish up this example from your 5.3 handout. We did part A and B in the last video. Part C, if I want to take the integral from -1 to 1 of 2f of x plus 3h of x dx, notice that's the integral of a sum, and I can rewrite that as the sum of two integrals. So that's my first step here. I'm going to rewrite this as the integral from -1 to 1 of 2f of x dx plus the integral 1 to 1 of 3h of x dx. If you think I'm taking too many steps, feel free to do this in fewer steps. You might have noticed that as you rewrote that sum, each one of those integrands has a factor, a constant factor that can come out to the front. So I'm going to write that it's the same as 2 times the integral from -1 to 1 of f of x dx plus 3 times the integral from -1 to 1 of h of x dx. And that is equal to, pretend this isn't here, it's just in my way as I'm writing, I know an expression for the integral from -1 to 1 of f of x dx. It is 5. So this is going to be 2 times 5 plus 3 times the integral from -1 to 1 of h of x dx is 7. So my final answer, 10 plus 21 makes 31. This next example, it's our first, probably your first example ever of this special kind of function. So just notice that we've talked about, in your lifetime, you've talked about functions f of x where the input was the base with an exponent. So you f of x equals x squared. You take the x value and you square it. Or f of x equals x cubed. You take that x value and you cube it. You have talked about functions where the variable is in the exponent. So y equals 3 to the x. Whatever your input is becomes the exponent on some base. And this is a brand new kind of function. It's a function where your input, the x, becomes the upper limit on an integral. So notice where the x is in this function. Here we go. This function, well, the definite integral in that function says I'm going to take the area under the f curve between 1 and some upper limit. And the thing that changes as x changes is how far along that function I go, accumulating up the area under the curve. So here, I'm sorry if your picture's a little hard to see. This is the place where x equals 1. I'm just describing this function so we can understand a little better before I try these guys here. This problem is designed to test our understanding of these rules for definite integrals, but we're going to want to understand what this function means before we can really move on through the rest of chapter 5. So imagine that blue line I drew, that's the place where x equals 1. If I wanted to find the area under f between 1 and 1, it would be the area of that line segment, but that's just it doesn't have area, it's just a line segment. Notice if I let x increase, maybe let x become 2, then the area I'm talking about is here, the area under that curve between 1 and 2. If later I let x equal 3, I'm talking about this area. If later I let x equal 4, I'm talking about this area, which is this positive area, and I know I'm going to have that little negative area there. Later, obviously my function ends at x equals 4, but we have to understand what's happening here is I'm keeping that vertical line at x equals 1 fixed, sort of as one boundary. My curve, f of t, is another boundary, that's my top boundary, and then I'm sort of letting that right-hand boundary extend out depending on what value x takes on. So you can see I accumulate more and more area unless all of a sudden I hit here this x value of 3. Is it 3? Right, and then if my x becomes bigger and bigger, all of a sudden I'm starting to lose area because I have negative areas on the interval from x equals 3 to x equals 4. Okay, that explanation was about what this function means. It's going to be really important later. You could answer these three questions here without really understanding that function too much. Notice I've been asked to compute g of 1. G of 1 means take the original g function and everywhere you see an x, replace it with a 1. So if I see the integral from 1 to x of f of t dt, and I'm going to replace the x with 1, now I have the integral from 1 to 1 of f of t dt. Can I evaluate this limit, this integral? Yes, I can, because the lower limit and the upper limit are the same. Like I said, I'm going to have a vertical line segment. A line segment has no area. This area is going to equal 0. The top and bottom limits of my integral are the same. I have 0 area. If I want to compute g of 4, I'm going to take my original function here. I'm going to replace the x with 4. It's going to be the integral from 1 to 4 of f of t dt. What does that mean? That means I'm going to add in this positive blue area, and I'm going to subtract away this little red negative triangle area. Use whatever geometry you need to use to make that happen. Let's see. I'm going to look at my bigger picture. It's a little easier to see. So between 1 and 2, I see a trapezoid. The parallel sides are 2 and, nope, the parallel sides are 3 and 1. So I'm going to take their average. I'm going to multiply by the distance across. Well, that trapezoid only covers from 1 to 2, so I'm going to multiply that distance across is 1. And then I have a little positive triangle that covers the space between 2 and 3. That's going to be plus 1/2. The base is 1. The height is also 1. And I'm going to subtract away the little triangle that I colored in red in this picture. So that's 1/2. Again, that's a triangle with base 1 and height 1. So to me, these guys are going to cancel, right? So I'm going to have 4 over 2 times 1. G of 4 equals 2. Now when it's time to compute g of negative 2, we got to make sure we know what's going on. I'm going to clear this out. All right, so g of negative 2. Start by taking my function definition and replace the x with 2. It's going to be integral from 1 to negative 2 of f of t dt. Well, notice my limits are now out of order. If I want to put my limits into the right order, I can do that. If I want to change the order of my limits, however, I'm going to have the opposite answer. So that's where this negative comes from. I'm going to have the opposite of the result I get when I integrate from negative 2 to 1 of f of t dt. And now I see, when I look at the better picture, negative 2 to 1, that's a triangle. It's above the x-axis, so I'm going to find the area of this triangle. I still have a negative here. The area of that triangle is going to be 1/2. The base covers x values from negative 2 to 1. That's a distance of 3. So 1/2 base times height. The height is also 3. So g of negative 2 is the same as the integral from 1 to negative 2 of f of t, which is the same as the opposite of the integral from negative 2 to 1 of f of t, which is equal to negative 9/2. This is a great little problem from an actual AP test. Again, we're practicing using the properties for definite integrals. I have the integral from a to b of f of x, and I know that that is equal to a plus 2b. Can I find the integral from a to b of f of x plus 5? So I notice that I have an addition sign here in my integrand. I'm going to rewrite this integral as this sum of 2 separate integrals. So the integral from a to b of f of x plus 5 dx equals the integral from a to b of f of x dx plus the integral from a to b of 5. I already know the integral from a to b of f of x dx. It is whoosh, a plus 2b. Now how am I going to find the integral from a to b of 5? So there's two ways to think about it. Feel free to use whichever way works for you. We're going to learn a third way soon enough. Feel free to use that if it's better for you. You could think of that as the area under the curve y equals 5 between A and B. So that's a rectangle whose width is b minus a and whose height is 5. Or from the last section, you memorized some formulas that the integral of a constant is the constant times top limit minus bottom limit. You'll end up with the same thing. That's 5 times the quantity, b minus a. Now in the free response section, feel free to leave your answer like that, but here we have a multiple choice question. It's our job to simplify this expression, which I imagine you will find not too difficult. That looks like 2b plus 5b is 7b, and I have an a minus 5a is minus 4a. So 7b minus 4a.